Superposition. Superposition is a tool to help simplify complex circuits. Say you're given a circuit with multiple batteries, voltage sources, or multiple current sources, and you're wanting to find the voltage in a node, the voltage drop across the resistor, or the current going through a branch. Superposition helps you simplify it and find those answers. So basically, you solve the circuit assuming there's just one voltage or current source. You then repeat this for every voltage or current source in the original problem. And you combine all the answers you find for your voltage drops or your currents and superimpose all the solutions to find the ultimate answer. So step one, replace. So you choose one voltage or current source to analyze, and you replace all the other voltage sources with short circuits and replace all other current sources with open circuits. You then calculate and tabulate. So you analyze the simplified circuit using Ohm's law, KVL, or KCL, any other electrical concepts you may normally use to solve a simple circuit, and making sure to note the current flow and the voltage polarity. That's a really important step to make sure you get the right answer in the end. A good tip is to record those in a table to make it easier at the end to combine all your answers. Step 3, repeat this for every voltage source and current source in the original problem. And step 4, superimpose. So combine all the results and tables of all the simplified circuits to find the desired values for each node or voltage drop, making sure to include the polarity or current flow. So this is an example of a way you could superimpose them together. So in circuit 1, we found it was 3 volts. In circuit 2, we found the voltage drop was the opposite polarity at 5 volts. And circuit 3, the polarity was the same as circuit 1 and it's 10 volts. So adding them all up, you get 8 volts as your final answer to the more complex circuit. So let's do an example together. We have this one, we have 2 voltage sources and 3 resistors that we're trying to find the voltage drop across. This can be done for current as well, but in this example, we don't have any currents. We're trying to find all current sources. So first, you short each voltage source. So replacing them, so we have the 28 voltage source on its own and then the 7 volt on its own. You solve them as you would normally, finding the voltage drop across each resistor. And you repeat that for the second circuit that you've made. And again, finding the voltage drop at each resistor, noting down the polarities of each one. Then superimposing them together, you find the final answers for the voltage drops across each resistor in the original problem. And that's how easy superposition is.